Hi, we are going to talk about the chapter Atoms and Molecule. Thomson atom model, otherwise known as watermelon atom model, Rutherford atom model. So he only initiated the idea that a nucleus is present in the atom. A positively charged core. Inside we have protons. Hydrogen atom alone, it is completely holds good. But when you go for complex structure of atoms, Bohr atom model fails. ஒரு ஆட்டம்ல நம்பர் ஆஃப் புரோட்டான்ஸ் எலக்ட்ரான்ஸ் ஈக்குவல். So atom is electrically neutral, that is separate. So you should not say that Z is called number of protons or electrons. Isotopes means elements having same atomic number. So two different elements having same mass number, different atomic number. அப்ப ரெண்டு பேருக்கு கிலோகிராம் ஏன் யூஸ் பண்ணோம்? இப்ப எலக்ட்ரான், புரோட்டான், நியூட்ரானுக்கெல்லாம் காமனா ஒரு ஃபேமிலி. அந்த ஃபேமிலிக்கு பேர் தான் அட்டாமிக் மாஸ் யூனிட் ஃபேமிலி. Hi, we are going to talk about the chapter Atoms and Molecule. Very, very interesting chapter. Basic atomic physics and a few topics in nuclear physics. What is an atom? Different scientists paved the way for introducing the basic concept of an atom. Dalton's atomic theory only initially found out some basic things. Thomson is the first scientist who gave the model of an atom. According to Thomson atom model, atom has got so many positively charged core. In that, electrons are embedded. Embedded means fixed. The number of electrons present in each atom differs depending upon the type of atom what you are using. It is not the same. Number of electrons are different. So positively charged core, electrons are fixed. This is information, basic information Thomson has given. Of course, it has got many drawbacks. First drawback and major drawback is electrons are not fixed, electrons are moving. Second basic drawback here is he didn't talk about nucleus at all. Thomson atom model, otherwise known as watermelon atom model. Watermelon, after cutting, that red color part is the positively charged part, and the seeds which is fixed in it equivalent to that of electrons. It's only a comparative study, man. That's all. Black seeds are called electrons. That red piece what we are eating is called past. Like that and all, you should not. It's only a comparative statement. That's all. Next is Rutherford atom model. Age-old, experienced scientist Rutherford. He initiated the idea of alpha particle scattering experiment. What is the meaning of alpha particle scattering experiment? What for he has introduced this experiment first? He want to prove there is one thing present called nucleus. A positively charged core is present inside the atom. He only initiated the idea. Okay, so this is radium kept in lead chamber. Why it is kept in lead chamber, sir? Radium is a radioactive element. Alpha, beta, gamma radiations will come out, which is so harmful. So we are keeping inside the lead chamber. Lead can absorb these type of radiations. Iron, no. Lead chamber is more safer than iron chamber. So alpha particle is coming out. Later on in the second part of atoms and nucleus, we will discuss completely about radioactivity. That time we'll discuss about alpha, beta and gamma radiations. So alpha particle ray is coming out. This is gold foil. Foil means a thin sheet of paper. That is called foil. Gold foil. So Rutherford is using a gold foil. And he observed what is happening when this alpha particle is hitting the gold foil. He made many observations. One observation is nearly 95% of alpha particle passes through the gold foil without any deflection. Simply it passes through. And a few are deflected back. And exactly opposite direction, few are repelled back. What is the meaning, sir? Why it is happening? Most of the alpha particle passing through, you can understand that. But why few are exactly repelled? Why you are using the word repelled? Later on, we will see alpha particle is positively charged particle. Rutherford observed there exists a positively charged core called nucleus. So when this alpha particle coming closer, up to a particular point it travels and then repelled back, returned. Only few percentage, 2 to 3% only. The repulsion is due to the presence of nucleus, which has got a positive charge inside. So he only initiated the idea that a nucleus is present in the atom. A positively charged core. Inside we have protons. He only initiated the idea. Then all problems solved, sir? No. Here also we have some problems. The basic problem is, according to Rutherford, electrons while revolving around the nucleus radiate energy. So while revolving, radiating energy means what will happen, sir? This is nucleus, sir. Electrons are revolving around the nucleus. When electrons are revolving, if they radiate energy, every revolution, if they radiate energy, they will lose its energy. Finally, that electron will spiral and fall into the nucleus. Electron is negative in charge, nucleus, protons, positive in charge. So once the electron come into the nucleus means nucleus become unstable. Nucleus is unstable means atom is unstable. But actually it is not happening. Nucleus is very much stable, atom is very much stable. There is no question of instability at all. So assumption of Rutherford is wrong. Then comes Bohr atom model. Only the basic idea we are talking here. Second part in detail about alpha particle scattering experiment. Completely about Bohr atom model. It is a very big concept, Bohr atom model. We will discuss in the second part of atoms and nucleus. Bohr has revealed so many postulates. First postulate say electrons are revolving around the nucleus in a certain stable orbits. Without radiating energy, underline the word. They are not radiating energy. If they radiate energy only, they will spiral and fall into the nucleus. They are not radiating energy. So the problem of Rutherford is solved here. Then no energy produced at all, sir. There is energy production. When electrons jump from higher orbit to lower orbit, of course, atom has got so many empty space, man. They are divided into so many subshells. Say this is nucleus, different orbits, K shell, L shell, M shell, N shell, and all. N is equal to 1, first orbit, N is equal to 2, N is equal to 3, N is equal to 4, like that. So when electron jumps from higher orbit to lower orbit, it emits energy. So these are the basic postulates of Niels Bohr. Niels Bohr proved everything in atom model, sir. No, here there are problems. The basic problem is hydrogen atom alone. It is completely holds good. But when you go for complex structure of atoms, Bohr atom model failed. Thomson, Rutherford, Bohr, one more atom model came into the picture. Sommerfeld atom model. That also has got one problem. After this, all scientists put together, they produced one atom model that is known as vector atom model. So Sommerfeld atom model, vector atom model and all, it is not our concern at all. Maybe second part also we will not discuss, because for your engineering or your higher studies, you will discuss about it. Okay, sir. When you say different shells, how many electrons in each orbit? Every orbit has got fixed number of electrons. It is not Bohr atom model. Some other scientists proved that number of electrons present in the orbit is 2n square, where n is called orbit number. Say n is equal to 1. Number of electrons. What is the value? 2 into 1 square, 2 electrons. So second orbit, 2 into 2 square, 8 electrons. N is equal to 3, 2 into 3 square, 18 electrons, like that. So first orbit, number of electrons 2, second orbit, number of electrons, maximum number of electrons can occupy is 8. Third orbit, number of electrons is 18, like that. Sir, you give a specific example that is called electronic configuration. Aluminium 13Al27. Next, we will write what is called 13A. What is this 13? What is this 27 and all, sir? We'll explain later. So 13 number of protons or number of electrons. So 13 protons or 13 electrons. Atom is electrically neutral. It has got equal number of protons and electrons. So 13 electrons. How this is nucleus? First orbit, second orbit, third orbit. First orbit, how many electrons? 2 electrons. 2. So electronic configuration is 2, 8, totally 13 electrons, 3. Second orbit, 8 electrons. Third orbit, actually 18 electrons needed to complete. But for aluminium, we need only 3 electrons for the third orbit. So only 3 electrons. So it is not completely filled. The orbit where the electrons are not completely filled are called valence electrons. So the valency of aluminium is 3. Some cases we may have 5, some cases we may have 10. We don't know. It depends upon the type of element what you are considering. You can take boron 5b10. 5b10 means 2, 3. 5 electrons or 5 protons. 2, 3. What is the meaning? Outermost orbit 3 electrons. First orbit 2, next orbit itself 3 electrons only. 8 electrons it has to occupy, but boron has got only 5 electrons. Correct, Amma? So these are the basic things of electronic configuration and the valence electrons. Representation of an atom. Atom representation. X is a day. Z is called atomic number. A is called mass number. Atomic number means number of protons. Mass number means number of protons plus number of neutrons. Sir, atomic number means number of protons or number of electrons, sir. No, wrong. You cannot say like that. Previously, you told it has got same number of protons and electrons, sir. 100% that statement is true. ஒரு ஆட்டம்ல எவ்வளோ புரோட்டான்ஸ் இருக்குமோ அவ்வளோ எலக்ட்ரான்ஸ் தான் இருக்கும். அந்த ஸ்டேட்மெண்ட் தனி. இசட் அப்படிங்கிறது நம்பர் ஆஃப் புரோட்டான்ஸ், அவ்வளவுதான். ஒரு ஆட்டம்ல நம்பர் ஆஃப் புரோட்டான்ஸ் எலக்ட்ரான்ஸ் ஈக்குவல். So atom is electrically neutral. That is separate. So you should not say that Z is called number of protons or electrons. No, number of protons. So inbuilt, what is the concept? Equal number of electrons also we are having. Good. Now you come back. 13Al27. What is the meaning? Aluminum has got 13 protons. Z is 13. A is 27. A is called mass number, number of protons and number of neutrons. So I want neutron number now. So neutron number is equal to A minus Z. Subtract simply. 27 minus 13. So 14 neutrons we are having. So if you take aluminum atom, 13 protons, 13 electrons, and 14 neutrons you are having. Sir, aluminum nucleus, 13 protons, 14 neutrons. Nucleus, there is no question of electrons. Electrons are revolving around the nucleus. So when you consider an atom, electron will come into existence. When you consider a nucleus, it is protons and neutrons part only. Clear, Amma? Fine. Depending upon number of protons, neutrons category, you can classify the element into 3. Isotopes, isobars, isotones. Isotopes means elements having same atomic number but different mass number. Mass number different, atomic number is same. Example, 1H1, 1H2, 1H3, hydrogen, deuterium, tritium. Isotope of hydrogen. Everywhere the atomic number is 1, mass number is different. So this is an example for isotope. Uranium, 92U235, 92U238. Isotope of uranium. Same atomic number, different mass number. Isobars, two different elements, underline the word. This word should be there, otherwise the definition is wrong. Two different elements having same mass number but different atomic number. When you say atomic number is different, it cannot be same element. ரெண்டு அட்டாமிக் நம்பர் இருந்ததா எப்படி எலிமெண்ட் சேமா இருக்க முடியும்? எலிமெண்ட் should be different. புரியல சார்? 3Li7 4Be7. Here you see same mass number 7 and 7, atomic number 3, atomic number 4. Two different elements, lithium and beryllium. Same mass number, different atomic number. So two different elements having same mass number, different atomic number. 6C14, 7N14. See, same mass number, different. So two different elements. Isotones. Two different elements having same number of neutrons. Neutron number is equal for both the elements. That is called isotones. 6C14, 8O16. Neutron number I will calculate. A minus Z. What is it? 14 minus 6, 8. 16 minus 8, 8. So 8 neutrons each category, same. Two different elements. Correct, Amma? This is called isotones. Compared to all the elements, any particular solid you take, nuclear density is the highest value nuclear density only, nearly 2 into 10 power 17 kilogram per meter cube. Density of nucleus calculation we will see in the second part. 10 power 17 kilogram per meter cube, unimaginably high. You cannot imagine at all to any other element in the universe. Density of nucleus is the highest. Okay, fine. Atomic mass unit, that is called AMU. Average mass unit also we can say, atomic mass unit also we can say. Every element possesses some percentage of carbon inside. There is no direct method available to calculate mass of that particular element. So what they have done is they have calculated the mass of carbon. Why carbon they are taking, sir? We will come back to that. 1 AMU is equal to mass of 1/12 of C12 atom. Why C12 atom? Means 6C12 carbon element representation. So proton or neutron, common name, we will discuss later about it. That is called nucleon. Proton or neutron, common name we call it as nucleon. One nucleon mass I want to calculate. Calculate the mass of C12 atom. Divide by 12. You will get mass of one nucleon. That is nearly 1.66 10 power minus 27 kilogram. 1 AMU, atomic mass unit, mass value 1.66 into 10 power minus 27 kilogram. 1 gram means 10 power minus 3 kilogram. 1 gram. 1 milligram, 10 power minus 6. 10 power minus 27.26 zeros you have to put. Then only a number will come. Such a low value, proton and neutron mass. Electron mass is still worst. 9.1, 10 power minus 31 kilogram mass of an electron. 0.30 zeros. Then only 9.1 is coming. Such a low value. So, previously they are using atomic mass unit, mass of proton in terms of AMU, mass of neutron in terms of AMU, mass of helium atom. Any particular element, they were expressing in terms of atomic mass unit because, sir, your mass is 50 kilogram, 60 kilogram. உன்னோட மாசம் 50 கிலோகிராம்ல சொல்வீங்க, எலக்ட்ரானோட மாசம் 50 கிலோகிராம்ல சொன்னாக்க அது எப்படி சொல்ல முடியும்? உன்னோட மாசம் 50 கிலோகிராம்னு சொல்ற, எலக்ட்ரானோட மாசம் 10 பவர் மைனஸ் 31 கிலோகிராம். அப்ப ரெண்டு பேருக்கு கிலோகிராம் ஏன் யூஸ் பண்ணோம்? இப்ப எலக்ட்ரான், புரோட்டான், நியூட்ரானுக்கெல்லாம் காமனா ஒரு ஃபேமிலி, அந்த ஃபேமிலிக்கு பேர் தான் அட்டாமிக் மாஸ் யூனிட் ஃபேமிலி. Sir, I know only kilogram. Fine. So only we are writing like this. One AMU, this much amount of kilogram. If you want express in AMU, if you want to convert in kilogram, multiply by this over 1.005 AMU. Express in kilogram. 1.005 into 1.66 10 power minus 27. Multiply these two, you will get the answer in kilogram. Correct, Amma? So this is atomic mass unit. Then basic introduction of radioactivity I will tell in detail. In second part we will discuss law of radioactivity, alpha decay, beta decay, gamma decay and all second part. Elements whose mass number greater than 206 are capable of emitting radiations naturally by itself. You are not giving any external energy for those elements to emit radiation. Why that is greater than 206 you are telling, sir? Lead Pb 82, Pb 206. So lead is a stable state. It is not emitting any radiation. Uranium 92U235 is radioactive. Plutonium 239, radium, radon, all these things radioactive elements. They will emit alpha, beta, gamma radiations until it reaches a stable state. That state is lead 206. Found out by Madame Curie and Marie Curie. Henry Becquerel initiated the idea. Madame Curie and Marie Curie completely discovered this. For this only they got the Nobel Prize. What is the actual radioactivity factor? In second part we will do. Okay, ma? So interesting topic we have done for atoms and molecules. Two or more atoms we call it as a molecule, ma. Molecule is not something coming from heaven. Two or more atoms forms a molecule. That's all. Then Avogadro number. What is called Avogadro number? That all in chemistry separately we will deal. Okay. Thank you. Second part we will discuss atoms and molecules or atoms and nucleus study in the second part in detail. Thank you.